Hey everybody, Merle here, and today I'm going to talk to you about welding cast iron. Thanks for joining me. I have a very rare broken exhaust manifold, and it happens to be made out of cast iron. So I am going to show you how I would fix this cast iron manifold. I had a lot of problems getting this manifold off. It's off of a caddy, but we won't go any deeper than that. We have a crack that is on here, and inside the heat shield you can see that it was leaking for a long time, and the issue with that is the oxygen sensor will not be reading properly with false air in. So I wasn't even going to share this with you, but I thought, heck, why not? This is a great example of welding cast iron. I'm a bit of a greasy mess here, but let's just talk about it. So cast iron is very rigid. There are a few different kinds of cast iron. I don't know which kind of cast iron this is. There's gray, malleable, nodular. I'm not sure what it is. What I need to do is I need to put material on here that is going to be flexible. Cast iron doesn't move, it breaks. Some cast irons do have some flex to them and so on, but normally manifolds, they end up breaking. So I'm not sure, they're probably like a gray cast iron. And I need to have a material on here that is going to be able to move because the cast iron won't, and the material needs to. The rod that I always go to is this Architect Supercast 90. Now, I am by no way sponsored by these guys, but this rod is very, very good. It has an extremely high nickel content. It's Supercast 90. I think it might be 90% nickel, but it just works excellent. So nickel moves a whole bunch. And so when I weld this, what's gonna happen is I'm gonna weld it and I'm gonna peen it, and that rod, when the cast iron is moving, the rod is gonna be able to take up that movement. So this should be a long-lasting repair. There's lots of other ways of fixing manifolds, brazing, so on, but I always seem to go to this Supercast 90. It works really well. The one thing is this Supercast 90, I believe it's 58,000 tensile strength, and it moves a lot. It has enough strength to be able to weld this up. If it was completely broken, I'd probably have to prep it a bunch more. First of all, you want this thing cleaned up, free of oil and grease and so on. And depending on what you're doing, you might want to put it into the oven and heat it up so that the whole thing is hot when you're welding it. Well, this manifold is going to be a short-term thing on this car, relatively short thing, I guess we'll say. I can't get the oxygen sensor out. I can't heat this up. So the rod, when I'm prepping for this rod, I don't want to introduce a whole bunch of heat into this manifold that is not needed. So we are going to be doing short welds about 1 inch long, and then we're going to peen them. But we want to be at least, well, we want to be about 1/3 to halfway through this crack. So what I want to do is use a very small carbide bit on a die grinder and groove this out. And I want to make sure that when I'm doing it, I get at least that 1/3 to halfway through. And this rod realistically is that much stronger than this manifold, so it should hold totally fine. What I've done is I originally started cleaning up this cracked area, and now what I did is I took it and I have highlighted to where I can see the end of the cracks are, and I've ground past. So this crack comes down here, but it also Y's off here. And this crack on this end, it stops in this here. So make sure before you get carried away with anything that you prep this up and find those ends of the cracks, because if you don't end up harnessing the ends of the crack, you're going to end up as a weld making that crack go further. As you're grinding this out, you're gonna see the cracks a little bit better. You can see it in here, and this actually tails off this way. So I have to chase this crack a little bit more there. So when you're prepping this up, you really wanna watch careful. You wanna get the end of that crack. Got all the metal prep done on this that I need to for grooving it out, and I went probably half the thickness. You can feel it, how thick it is. So I've chased the cracks to the ends to wherever I can find them. Now, the next very important step is we don't want any oil or grease or anything on this to cause porosity in the weld. Now, porosity in the weld is, it's the least critical weld fault, but we still don't want it. And what porosity is tiny little air bubbles in, and if you have too many, of course, that's a big problem. We don't want any. Cleaning this now, a lot of people are going to be tempted to use brake clean. Absolutely, brake clean is going to work good. I'm going to be using it on this, but the thing with brake clean is you have to use non-chlorinated brake clean. Anything with chlorine in it that you're going to clean this with, when you expose chlorine to, I believe, UV light, you end up with phosgene gas. And phosgene gas is a gas that will kill you. So if you have brake clean on here that has chlorine on here and you light this up with the welder, you're going to have UV light hitting it and you're going to end up breathing in poisonous gas. Not a good thing. So what I'm going to do around this weld is I am going to take and I want to burn the oil out of it. I don't want to heat this thing up where it is getting the manifold necessarily hot. I just want it hot enough that I'm going to burn the oil out of the crack. You can see oil in the crack. This thing was hard to get off the car. I had to use a lot of penetrating fluid on it. I have broken bolts everywhere. And what I'm doing is just cooking that oil out. Cooking the oil out, I mean, I did not get this hot, but it was smoking. And as well, you can really see after you've done that, it highlights the, ooh, that is warm right there. It highlights the crack in there. All of that garbage that's still in the crack, I want to try and get it out. And I'm going to cook it a little bit more, and then we're going to take and we're going to wire wheel that and grind off the outside edges of it to have it perfectly prepped. So I have a 36 grit sanding disc on my little 90-degree die grinder, and I'm just going to prep around this a whole bunch more to get rid of that surface contamination that might be in the pores of the cast iron. I have the surface all prepped on the outsides of this. If you look in here, you can see that there's that layer of burned carbon from all the garbage that's burned off inside. You can see the difference. There's kind of a line there, but the bottom of that is completely black, and I am just going to wire wheel it off. Just a simple little wire wheel and a drill. Cast iron is very high in carbon, and you're going to have some carbon smear and whatever. But what we're going to be doing is getting set up to weld this next, and that is how I would want it look to be prepped. And let's get a rod and get going. There are options on these rods if you look in the instructions, but what I weld it is DC EP, so reverse polarity, DC current, electrode positive. When you're welding that, what happens is the ground side of the welding process, which will be this manifold, is going to have 2/3 of the heat energy and 1/3 will be in the rod. What that's going to do is it's going to give me a nicer, deeper penetrating weld, and that's what I'm looking for. This rod kind of welds like worms. It is ugly to weld. You're not going to put the most beautiful weld down. But even after that, when the weld is on here, you're going to weld very short because we don't want to heat shock this thing too much. You're going to weld short, and then that nickel that you put in there, what you're going to do is you're going to take a hammer and you're going to peen it. And what that's going to do as it's cooling, peening it, is it's going to convince it to move with that metal as it is moving, because the cast iron is going to flex, and this nickel, what we're going to do is convince it to move with the cast iron. So short weld and peen. I'm running a 332 rod, running about 90 amps. All right, what I'm talking about is this looks ugly. What I've done is I made 2 passes. I had 90 amps, but I'm definitely going to be turning it down. I would say maybe 75 amps near the lower end, because yeah, it's putting too much deposit down. But this is actually going very good. I'm going to get the other end, and I'll just keep making a bunch of short welds, and then we're actually going to grind it off, because that looks like sin. So turning it down definitely helped. I would say, yeah, that's 75 amps. I'm at 77 amps is working really good. And you want to, because you're not preheated, you're going to want to do shorter, little tiny welds. If you're preheated, you could go longer and you might not have to peen as much because you'd be throwing it back in the oven. But we aren't doing that in this case. There is the ugly worm sitting on there. What I'm going to end up doing is I'm going to grind it off. If there's any impurities in there, there might be some porosity or something in some spots. One spot actually looked like it was some coming in. I'll prep that out, grind it out, and the reason this is getting covered with a heat shield, and the reason I'm gonna actually take and grind this off is I don't want that heat shield to vibrate on here, even though no one's gonna see this weld. It'll look better ground off too. Well, the porosity is in there that I thought was going in at that spot, as well as where the welder was turned up too much, I ended up with undercut, so a little groove on the outside of the weld. You can see in there, I still have a little bit more. I'm gonna prep that out and get rid of that. Welding cast iron, you're definitely not gonna have the prettiest weld, but when you grind it off, it doesn't look bad. This is gonna be an extremely strong weld. I know that for a fact because this is the same process that I have used for years, and it has been very successful on any cast iron, big equipment, everything. I'm gonna have to end up getting out the rest of the bolts that are broken off in this car and get it back together. So thank you for watching, and please like, share, and subscribe.